These are the video notes for section 2.1, constant velocity motion. Let's start with our first example. Mike walks 1 mile to school in 20 minutes and then walks back home in 25 minutes. First question is, what is Mike's average speed in meters per second? To calculate speed from the equation d equals v times t, we're going to plug in his distance, total distance traveled. Okay, so he travels 1 mile out and then 1 mile home, or the total distance traveled is 2 miles. Now I'm going to go ahead right now and convert this into meters so that when I plug into my equation, my answer can be in meters per second. 2 miles is 3,218 meters. The total time of travel is 20 minutes out plus 25 minutes back, or 45 minutes total. That's 2,700 seconds. Now I can use the equation d equals v times t, plugging in distance of 3,218 meters, divided by the total time of 2,700 seconds, gives me an average speed of 1.2 meters per second. Now let's answer the question, what is Mike's average velocity in meters per second? Now velocity, if I'm going to solve for velocity using d equals v times t, I need to plug his displacement into the equation. And displacement takes direction into account. So Mike walked 1 mile out, turned around and walked 1 mile back. His total displacement is 0, which of course is 0 miles is 0 meters. Same total time, plugging into the equation, you get an average velocity of 0 meters per second. Okay, let's take our first quiz. All right, let's do example number 2. A car travels at 40 meters per second for 10 seconds, then continues at 25 meters per second for 8 more seconds. What is the car's average velocity? So we have to look at this trip. If we're solving for average velocity, we have to look at this as having 2 legs to the trip. If I want to solve for the average velocity for the entire trip, I need to have the total displacement divided by the total time. So in the first part of the trip, he travels at 40 meters per second for 10 seconds. So the first part of the trip, he will cover a total displacement of 400 meters. During the second part of the trip, he travels at 25 meters per second for 8 seconds, or he'll cover a total displacement of 200 more meters, both going in the same direction. So the total displacement traveled during this trip is the sum of the 2 individual legs of the trip, or 600 meters total. Now that we know the total displacement covered during the trip, we can take the total displacement divided by the total time, 18 seconds, and this will give us the average velocity for the trip, 33.3 meters per second. Let's take quiz number 2. Okay, let's do example number 3. Jack flew 678 miles east from Springfield, Illinois to Richmond, Virginia in 1 hour and 57 minutes. He then flew 236 miles west from Richmond, Virginia to Charleston, West Virginia in 45 minutes. The question is, what is his average speed during the trip measured in miles per hour? Okay, we're going to use the equation d equals v times t. And to calculate his average speed, we need to use the total distance traveled divided by the total time of travel. The total distance traveled is 678 miles plus 236 more miles, or 914 miles. The total time of travel is 1 hour and 57 minutes, which is 117 minutes, plus 45 more minutes, for a total of 162 minutes. Plugging into the equation, you do 914 miles divided by 162 minutes gives you an average an average speed of 5.64 miles per minute. But we were asked to put our answer in miles per hour, so we need to convert the minutes to hours, or 338 miles per hour. Now let's calculate what the average velocity is during the trip. Velocity takes direction into account, so as I plug into the equation d equals v times t, I need to first plug in the total displacement. The displacement for this trip is 678 miles in one direction, minus 236 miles in the other direction, or 542 miles to the east in this case. Plugging that value into d equals v times t, along with the same total time of 162 minutes, we find that the average velocity for the trip is 3.35 miles per minute. Or, placing that into miles per hour by multiplying by 60, we get 201 miles per hour. And this is positive, and you can see from in the first part of the problem, we assigned east as the positive direction, so this is 201 miles per hour to the east. Okay, moving on to example number 4. The moon is 384,400 kilometers from Earth and takes 27 days, 7 hours, and 43 minutes to circle the Earth one time. What is the moon's average speed on its orbit around the Earth in meters per second? Okay, so to calculate speed, we're going to use distance divided by time. The distance the moon travels during one orbit around the Earth is going to be equal to the circumference of the circle it draws around the Earth. So to calculate the circumference, or the distance the moon travels, is 2 pi r. So we take 2 times pi, which I've placed here as 3.14, but I usually use the pi button on my calculator to calculate anything with pi in it, times the radius of the moon's orbit, which is 384,400 kilometers, but I'm going to go ahead and place that in meters so that my answer can be in meters per second. So that's 384,400,000 meters. Or 2.42 times 10 to the 9th meters on the moon's orbit around the Earth. So that's the distance traveled. So to plug into this equation to solve for the velocity, I'm going to need to know the total time of travel. I want my answer in meters per second, so I'm going to go ahead and convert my time into seconds. So the time is 27 days, and 27 days in seconds is 27 times 24, so we're in hours, times 3,600 to convert to seconds. Plus 7 more hours, and 7 hours written in seconds is 7 hours times 3,600 to convert to seconds. Plus 43 minutes, and 43 minutes written in seconds is 43 times 60 to convert to seconds. Add that all up, and you get 2.36 times 10 to the 6 seconds. So we have the distance the moon travels divided by the time of travel gives us an average velocity of 1,025 meters per second. Okay, let's take quiz number 3. And let's do example 5. 2 runners are running in a 10-kilometer race. Runner A starts in the first group of runners and is running at 5 miles per hour. Runner B starts 5 minutes later with the second group of runners and is running at 8.5 miles per hour. How far are the runners in kilometers from the start line when runner B overtakes runner A? So the one thing that we notice here in the variables distance, velocity, and time is that for both runner A and runner B, they're going to be running the same distance. The problem begins at the start line, as far as distance is concerned, and ends when the 2 runners are side by side. Okay? So the fact that it's a 10-kilometer race has very little to do with the problem. Technically, it has nothing to do with the problem. Okay, distance is equal to velocity times time, so I'm going to plug in velocity times time for both of those distances. So we've got the velocity of runner A times the time it takes runner A to get to the point where the 2 runners are side by side is equal to the velocity of runner B times the time it takes runner B to get to that point. Okay? So we can plug in the values for velocity because those were given to us. Runner A runs at 5 miles per hour, and runner B runs at 8.5 miles per hour. Now I'm going to go ahead and convert these times to kilometers per minute instead of miles per hour. The reason why I chose kilometers per minute is because the time, the 5 minutes later start time for runner B, is given to us in the unit of measure of minutes. And the final answer, I'm looking for my final answer to be in kilometers. So I want to work in the unit of measure kilometers per minute. There's more than one way to attack this problem, and as long as you're using consistent units of measure in your equations, you could do this problem in miles per hour, converting your time of 5 minutes to hours, and then getting an answer in miles, later on converting it to kilometers. So like I said, there's a lot of ways to start the problem. This is just the one that I've chosen to take. Okay, so now we have an equation that contains two variables, time of runner A, time of runner B, and we need to solve for one or the other to help us get to our answer. But we do happen to know how these two variables are related to each other. We know that runner A started first, and 5 minutes later runner B started. So runner A's time is going to be equal to runner B's time plus an extra 5 minutes of run time. So I can use that and plug into my equation over here where I had TA, I can plug in TB plus 5. Now at this point you'll notice that I've dropped off my units of measure from my equation. The equations can get a little bit messy if you're carrying all your units of measure through all the time. I chose to drop mine off here because I was careful by this point to make sure everything was in consistent units of measure. So I'm going to work this algebraic problem here without having to worry about my units of measure. So I've done two steps here. Distribute 0.13 on the left side of the equation, and then subtract the term 0.13 TB from the left and right side of the equation. That leaves us with 0.65 on the left side of the equation and 0.1 TB on the right side of the equation. Dividing both sides by 0.1 gives me a time for runner B of 6.5, and of course I was working in the unit of measure of minutes, so that's 6.5 minutes. Now this isn't my answer to the problem, but it helps me get there, because what I want to know is how far the runners are from the start line. Okay, well I know that from the start line to where the runners meet side by side took runner B 6.5 minutes. I can use the equation D equals V times T in order to calculate how far the runner has gone in those 6.5 minutes. Now this is runner B's time, so I'll have to plug in runner B's velocity. So 0.23 kilometers per minute times 6.5 minutes gives me a distance for runner B of 1.5 kilometers. Runner B will be 1.5 kilometers from the start line when he overtakes runner A.